2018 Leaving Cert Higher Level Paper 2 Question 7. We're told that this is a garden fence and the volume of each sphere from B to E is 1.75 times the volume of the previous sphere, and you're asked to find the sum of the volumes from spheres A to E. Okay, if we can get A, we can use the sum of the geometric sequence here. A is equal to 4/3, capital A, 4/3 pi by 3 cubed, which we type into a calculator, we're going to get 113.1. So that is going to be, there's going to be another number, 2, 3, 4, 5 of them. So the ratio, you could just multiply by 1.75 and add these numbers together. Some people might prefer that, but this is the geometric series where A is equal to 113.1 and R is equal to 1.75. And maybe do it both ways and check that you get the same answer both ways. So putting that into the formula for the sum to n is going to be A times 1 minus R to the power of n over 1 minus R. So the sum of the first 5 terms, 1, 2, 3, 4, 5, 5 is equal to 113.1 by 1 minus 1.75 to the power of 5 over 1 minus 1.75. So the negatives will make it positive. So the sum of the 5 are, typing this into our calculator, I get 2324, correct to the nearest centimeter cubed. If we type them in individually, we're going to get 113.1, 197.93, 346, just multiply by 1.75 each time, 346.37, just rounding off the 2 decimal places, 606.15, and the last one would be 1060.75. So you could just add all of those together, you should get the same answer. Part B of this question, we were told that the surface area of E is 503 centimeters squared, and we know that surface area is 4 pi r squared for a sphere. We're asked the height of the railing at E, including the height of the bar and the sphere, is 1.2 meters as shown in the diagram, and find the height of the bar E. Okay, so we obviously need to find the radius. There's 2 of them there, so take 2 of the radiuses away from 1.2. We get the height of the bar. So 4 pi r squared is 503. R squared is equal to 503 over 4 pi. So R is equal to the square root of 503 over 4 pi. So just type that into your calculator and you're going to get R to be 6.326 by 2 is equal to 12.65. That would be in centimeters. So 120 centimeters, take away 12.65 centimeters is going to give 107.35 centimeters. B part 2, we're told that the radius of each bar is 1 centimeter and the heights of the bars A to E form an arithmetic sequence, so the same difference between each bar. Find in centimeters the volume of each bar and the volume of bar A, sorry, the height, let me just, it's the height of each bar, not the volume. So what have we got? We've got the height of bar E, so here's E, and it's 107.35. Let's just leave it at 107.3 for now. Bar A, we have the volume, so pi r squared h is equal to 71.3 pi. Knock off your pi's, r is equal to 1, so 1 times h is 71.3, so the height of bar A is 71.3 centimeters. So we have E, we have D, see how many jumps there are, we have C, B and A. So there's 1, 2, 3, 4 jumps. So let's look at the difference between these. 107.3 minus 71.3 is equal to 36. Okay, so divided by the jumps 4. Each jump is going to be 9 centimeters. So A, 71.3. B would be 80.3. C, 89.3. D, 98.3. And you can see there, if we add 9 to that, we're going to get 107.3, the height of each bar. The next part of this question, we're told there's a wall either side. So these blue lines here, just coming back up to the first diagram. These walls are 1.5 meters apart, and the gap between the wall and the first column or the first cylinder height is 20 centimeters. So we can see that from the beginning of this one to the end of this one is going to be a total of 1.1 meters or 110 centimeters, and we're looking for the gap in between each one. Well, how many gaps are there? 1, 2, 3, 4, 5, 6, 7, 8 gaps. Okay, so let's have a look at the solution to this one. So we've 8 gaps. We've got 8 gaps. The total distance is 110 centimeters. There's 9 bars, each of radius 1, so the diameter is 2. So multiply that 9 bars by the diameters, we're going to get 18 centimeters, which leaves 110 minus 18 leaves 92 centimeters for 8 gaps, and 8 into 92 is 11.5. 88 and 4 is 92, 11.5 centimeters. In the next part of this question, we were asked to find the length of this rod, this black rod, the shortest rod that could connect A and B. So what do we need here? We need to get this radius, we need to get this distance X, we need to get this distance Y. So there's a little bit of work involved in this one. Well, X is going to be, we've just worked out the distance between here and here, and the radiuses are 1, so X is 11.5 plus 2, which is 13.5. The radiuses and Y, well, let's look at Y first. The heights, the height of the bars were this and this. So if we just do a little, well, we have the heights of the bar. Let's just do a little sketch of the heights of the bars. There's A, and there's B. It's obviously not drawn to scale. This is 71.3 and 80.3, and this distance here is the radius. .959, and this question asks correct to the nearest centimeter the rod, so the rod would be equal to 10 centimeters.